We will discuss about the various cases in AVL tree. So before going to AVL tree, you should need to know what is binary search tree. So you have a pretty good understanding about what is binary tree, right? What is binary tree? So what is the difference between a general tree and a binary tree? See, Braun, show me what is the difference between a normal tree and a binary tree. How does a general tree looks like? How many nodes does it have? N number of nodes. So in case of general tree, any node can have, if you take any node, it can have any number of nodes. So the number of nodes is not limited. However, if you all together, the total number of nodes is of finite count. We cannot say infinite number of nodes will be present in that particular tree. So this is general tree. So a node is definite, can have 0 child or it can have 1 child or more than 1 child. So when it comes to binary tree, each node will have 0, 1 or 2 children. This is a binary tree. So any node can have 0 child. If there is a node like this alone, it is a binary tree. This is having 0 child. Any node can have 1 child. Still it is a binary tree. If a node can have more than 1, 2, can have, if it has exactly 2, this is also a binary tree. So 0, 1 or 2. So this is binary tree. In binary tree, if all the values in the left subtree is less than the root and all the values in the right subtree is greater than the root, it is binary search tree. For example, consider this. Can this be considered as binary search tree? Yes or no? No. What is the root value? 1. Values on the left subtree is not less than the root. So this is binary tree but not binary search tree. Take this example. All the values. First, this is again a subtree, right? This is entire tree, this is a subtree. Again you have to check. So for this particular node, this is the root. So values in the left subtree is less than the root. Values on the right subtree is greater than the root. Here, values on the left subtree is less than the root. Values on the right subtree is greater than the root. Here. So this is binary. This is both binary tree as well as binary search tree. Now, let me draw a tree like this. Tell me what is a drawback. There is a tree like this. This is a binary search tree. This is a binary tree as well as binary search tree. All the values on the left subtree is less than root node. What is the drawback with these kind of trees? This is a skew tree, right? What is the drawback with this tree?
Branches on the left side.
What is the drawback?
Right side.
What is the main advantage of binary search tree over
right side?
Okay, that's fine. What is the advantage of binary search tree over binary tree? In binary tree, values are not orderly stored. We cannot locate if the value is present in left subtree or right subtree, right? But in case of binary search tree, I can locate the value by comparing it with the root node. For example, if I want to search 6, initially we will compare 6 with the root node. So 6 is less than root. So obviously this value has to be present in the left subtree. So if I perform search only on the left subtree, it is enough. But in case of binary tree, I cannot do like that. For example, in case of binary tree, if it is taking 10 comparison to find a value, in case of binary search tree, it will take only 5. Because the value is either present in the left or in the right. So in this case, as he said, I can perform search only on the left subtree. However, assume your root node value is 100. So it has all the 100 nodes on the left subtree and the last leaf node value is 1. If I want to search the value 1, how many comparisons is required? 100 comparison is required, which is time consuming. This is not advantage, right? So binary search tree or advantage another time is reduced by half, but here it is not reduced by half. So in case of degenerate or skew trees, it is not, time complexity is increased. So why it is increased? Because the tree is not balanced. Balanced and together. One side but two it is tilted, so tree is not balanced. So to balance, so this is a drawback of binary search tree because in binary search tree is not always balanced. AVL tree is a balanced binary search tree. Understood? So AVL stands for Adelson-Velsky, Landis. So these three are the person who invented this tree, AVL tree. So AVL tree is a balanced binary search tree. So first, if you want to find if it is an AVL tree, it has to be binary search tree by default. First, it has to satisfy all the conditions of binary search tree. So what are the conditions? All the values on left side should be less than root and all the values on the right side should be greater than root. So it has to satisfy the property of binary search tree. Next, it has to be balanced. So how to check if a tree is balanced or not is, you have to find the height of every node. So if the height of every node is either -1, 0 or 1, then we can say the tree is balanced. Clear? So height, how to find the height is that, how do we find the height? If you want to find the height of particular node, from that particular node to the leaf node, number of edges is taken as the height, right? So for example, take this tree. Let me draw the nodes alone. What is the height of this node? What is the height of 2? Calculating the height of this particular node is height of left subtree minus height of right subtree. What is the height of left subtree? 0. Height and the calculator from that node to the leaf. Leaf we do not have any path. So height of left subtree is 0. Height of right subtree again 0. 0 minus 0 is 0. So height of this node is 0. What is the height of this node? What is the height of left subtree? 1. We have only one edge. 1 minus 0. So height of this node is 1. Here 2 minus 1, 1. Here what is the height of this node? 5 left. We have only left subtree 0. So here all the nodes has either -1, 0 or 1, which means this tree is balanced. So this is AVL tree. Now take this case. 4. Height of 1? 0. Height of 2? 1. Height of 3? 2. 2 minus 0 is 2. Here height of 4? 3 you can stop. Inge it does not satisfy the balance functions, right? So it is not balanced, which means this tree is binary search tree but not AVL tree. So if a tree is not balanced, to convert it into AVL tree, we have to perform 4 kind of rotations. Rotations has to be performed to convert an unbalanced binary search tree to AVL tree. So there are 4 kind of rotation. One is left rotation, right rotation, left right rotation, right left rotation. So there are 4 rotations.